Hello, and welcome to our presentation. We are the Corona Weather Reporters, and we will be going over our study of weather effects on COVID-19. COVID-19, or coronavirus, which originated from China, has become a global pandemic. This has given us the opportunity to use pertinent and updating datasets to analyze if aspects of weather such as humidity and ozone levels have an effect on the coronavirus. We picked this topic to research as there have not been nearly as much study on this as other topics and would make for an interesting research subject.
We have many inspirations for choosing the coronavirus topic in relation to weather. As we have seen in 2003, there has been the SARS pandemic. The SARS pandemic shares similarity to COVID-19 in its country of origin, climate, scale, and transmission. Both viruses have originated from China. Also, they are prevalent in locations with similar climates, and since they're pandemics, they have been on a large scale. Their method of transmission is usually through fluids. Now let's take a look at our data sets and graphs and the information we obtained from those.
While doing research for our project, we found various other studies done similar to ours. They did simulations using weather data and coronavirus outbreaks to see if there is a slight correlation between the two. In some of the studies, they found that there was a slight correlation between humidity and coronavirus outbreaks. This backs up our project with additional support of how corona may spread with external factors such as ozone and humidity.
We decided to start our research by investigating ozone levels globally. Ozone levels indicate how much UV rays penetrate throughout the atmosphere, which could decrease corona's survival rate in the environment. So we decided to analyze the average ozone levels of countries with at least 10,000 cases. We ended up with a small list of 29 countries. Here we can see two graphs of ozone levels over latitudes of countries. The y-axis indicates ozone levels, which is measured in Dobson units, and the x-axis includes the country's latitudes. Here we can see that the ozone levels seem about the same over latitudes on two separate dates. There is a more than month difference between these dates. However, the ozone levels seem to be the same. On this map, we can see how ozone levels change between the two dates at different geographical areas. This map shows the same data as previous graphs, as the changes in ozone are small. To prove this, we look at our descriptive analysis where we see that the mean remains about the same, even though a standard deviation changes about 10% of the mean. Next, we tried seeing if there was a change in ozone in small geographical areas, such as these three California counties. As we can see, the standard deviation of all three counties are very small, about 10% per standard deviation. The mean and standard deviation of these three counties show that ozone doesn't differ much day to day over many months. Next, we used humidity for our research. By investigating humidity levels, we can see how much humidity changes globally. We used humidity since it can contribute to protecting COVID-19 particles. COVID-19 is a SARS virus, which is transmitted by droplets, so humidity can contribute to its spread. We narrowed down the countries to investigate to 29. Here are our graphs to visualize how diverse humidity is. As we can see, humidity has a wide range of being very high or very low. With this type of separation, our trend line appears almost flat, with a slope of around 0.08 between both these dates. Here we can see that the standard deviation is about 30% of the mean on both dates, which shows that humidity varies significantly from the mean. This supports our observation of the graphs. Here is a visualization of humidity on a map between these two dates. We also did some analysis to see if mortality rate differed between countries, to see if there would be any indication of climate effect. As shown here, we can see that mortality versus confirmed cases is relatively flat, except for one outlier, with many countries having very low mortality rate with very few exceptions, as shown by the trend line of having a slope of less than 0.01. We can see similar results on the graph on the right that shows that latitude doesn't affect mortality rate much either, with the trend line slope of less than 0.01. Here is a map of mortality rate by country. Higher mortality rates happen in countries with very low confirmed cases, so there are outliers since they don't have enough of a sample size.
With humanity and ozone out of the way, we decided to concentrate our research within the United States specifically. The United States has about 33.8% of COVID-19 cases internationally. we specifically chose California in the United States because we are residents of California, and California is one of the largest hubs of COVID-19 within United States. And in this graph, we can see the trend line for Orange County within the last 30 days. And you can see here that that is very steep. The trend line says that there's about 55 cases per day within the last 30 days. So every day, there's 50 new cases. With this in mind, we decided to choose several counties within California to analyze the effect of weather on the cases. So here are 3 counties that we chose. In each county, we have many attributes such as max temperature, minimum temperature, humidity, and ozone. And then we have these attributes for each date since the new year. In this graph, you can see our exploratory analysis of minimum temperature in Orange County. As you can see here, minimum temperature in Orange County looks pretty much consistent. It's all within the range of 45 to 55 as shown in the graph. This is further proven with our descriptive analysis that our mean is 50 degrees Fahrenheit and the standard deviation is 3.4. So with a standard deviation of 3.4, that means that each iteration, like groups of temperatures, they're only 3.4 away from the mean. So maybe some days it will be 50, some days it will be 47, maybe some days it will be 53. So they're all within a 10-degree range, which is very consistent. So with this, we can assume that the minimum temperature won't have much effect on corona in Orange since it does not fluctuate. However, in this next graph, as you can see, the max temperature is all over the place. And with this, we can definitely say that max temperature will dictate how much corona will spread, since days with higher temperature will slow down the spread of the COVID-19.
It's interesting to point out that as latitude of the countries increases, the mortality rate slowly increases and then decreases. 20% was the highest mortality rate, with latitudes ranging from 20 to 40. Beyond that, mortality rates start to decrease sharply to 0. As shown in our humidity and ozone level graphs, both show a positive correlation between humidity, ozone, and latitude of countries respectively. Beyond latitude 40, humidity increases from 40 to 60%, and ozone levels increase up to 350 Dobson units on March 14th. Also, many counties in California show consistent climate patterns in humidity, ozone, and minimum temperature, whereas max temperature varies. We can see that around latitude 40, many locations have humidity ranging from 60 to 90, and ozone levels ranging from 275 to 350. At this latitude, there are more coronavirus cases than other latitudes. At first, this point is shown further evidence as the standard deviation of ozone was low, which is very small. By using this data, we realize that ozone doesn't have any significant change over time and will most likely not contribute to the coronavirus spread. It is also worth noting that the standard deviation of minimum temperature to remain consistent for California counties from the standard deviation, thus making it not as useful as max temperature. By using past and contemporary data of coronavirus and weather, we can make predictions on how coronavirus will spread in the future. Along latitude 40, cases of coronavirus will exponentially increase as time goes by. Based on our research, it is advised to follow whatever necessary procedures to prevent coronavirus spread. Latitudes with moderate to high weather had the most cases of corona. No matter what latitude, coronavirus can still exist and appear. Coronavirus shares many similarities with the SARS virus in its country of origin, climate, scale, and transmission. With such similarities between these two viruses, it is worth noting that SARS is directly affected through environmental factors such as the weather. Based on our research, weather does have an effect on coronavirus. We can see that the number of confirmed cases varies differently based on humidity. Countries located on the 40th parallel north, which spans across the US and China, will see an exponential increase in coronavirus cases as the weather becomes warmer. In our research, we decided that since the ozone standard deviation was low, it does not provide enough direct evidence in affecting weather, other than being consistent in our graphs data. Coronavirus is still spreading nearly everywhere. There are more than 152 countries that have coronavirus cases. We are against the clock. We must do as much as possible in order to flatten the curve and stop the coronavirus pandemic. Here are our references.